Welcome to the Deep Dive, the show that extracts the most important insights from cutting-edge research. Today, we're tackling a challenge that's been looming pretty large over the world of large language models, the data wall. It's this pervasive problem where simply feeding more and more internet data into LLMs just isn't giving us the breakthroughs it used to. We've sort of hit a ceiling.
Yeah, it's a real bottleneck people started hitting.
Yeah.
More data wasn't always translating to better performance anymore.
Exactly. So our mission in this deep dive is to unpack a really cutting-edge solution to this data scarcity. It comes from the Datatology AI team. We're diving into their paper, BeyondWeb, Lessons from Scaling Synthetic Data for Trillion-Scale Pre-Training. This is basically your shortcut to understanding how intelligently generated synthetic data is pushing the frontier of LLM performance.
It's fascinating stuff, really looking at how we move past just scraping the web.
Okay, so for those of you who need this super quick version, maybe for a short form edit, here's your 1-minute summary. The big idea is BeyondWeb. It's a synthetic data framework that dramatically improves large language model pre-training. So not just more data, but higher quality, information-dense synthetic data. They do this through clever rephrasing of existing web content.
Right. Rephrasing, not just generating from scratch. That's key.
Key breakthroughs. BeyondWeb outperforms state-of-the-art synthetic datasets like Cosmopedia and Nemotron-Synth. We're talking up to 5.1 and 2.6 percentage points across 14 benchmarks.
Pretty significant gains there.
And the efficiency is stunning. Training with BeyondWeb is up to 7.7 times faster than open web data.
Yeah, 7.7 times faster. That's a huge saving in compute.
And here's the kicker. A 3 billion parameter BeyondWeb model actually surpasses an 8 billion parameter model trained on Cosmopedia. That points to a whole new Pareto frontier for LLM accuracy and efficiency.
Doing more with less, essentially. It challenges the bigger is always better idea.
Totally. The core insight. High-quality synthetic data isn't simple. It needs careful optimization across many factors. Source quality, generator choice, diversity, lots of things.
It's definitely not a plug-and-play solution. There's real science to it.
Okay, let's unpack this properly then.
Yeah.
The data wall, it sounds dramatic, but you said it's a very real problem we encountered around 2024. Development hit a ceiling. High information density web data just became incredibly scarce. What exactly does that mean for someone, trying to build the next big language model?
Well, for a long time, the recipe for breakthroughs in language modeling was pretty straightforward. Train bigger models on exponentially larger internet scrape datasets. But by 2024, as data collection scaled into the trillions of tokens, that strategy just started to yield diminishing returns. The internet, maybe surprisingly, has a finite amount of truly high-quality, non-redundant data.
Right. It's like trying to get more water from a well that's almost dry eventually. You're just getting mud.
That's a good way to put it. At some point, you're just processing lower quality stuff or repeating things. So researchers had to look for alternative paradigms.
That's a great analogy.
Mm-hmm.
So what did researchers turn to first when the well started to run dry? This led to the first wave, right? The generator-driven approaches. Tell us about those initial efforts.
Yeah, the first wave. Initial efforts like Tiny Stories and Microsoft's Phi family, and then later the open source Cosmopedia, they used large LLMs like, say, GPT-4 or Mixtral 8x7b to generate training data de novo.
De novo, so from scratch.
Exactly. Essentially, they prompted these powerful models to create entirely new knowledge or text that looked like knowledge. It was a groundbreaking idea, actually. It showed you could train smaller models effectively on this purely generated data.
Generating knowledge from scratch sounds incredibly powerful, but from a practical standpoint, what were the immediate hurdles or maybe unforeseen drawbacks these early generator-driven approaches ran into?
Well, yeah, powerful in concept, but they were ultimately constrained by a few things. One was the sheer computational cost of using those state-of-the-art generators like GPT-4 made them less accessible. They also struggled with scalability and were kind of susceptible to issues like model collapse.
Model collapse.
Yeah, where the model starts generating repetitive or nonsensical stuff over time. And they inherited biases from the generator model, had limited diversity, coverage gaps, sometimes even hallucinated content. They were basically replicating the knowledge and biases of the big source model, not necessarily expanding it much.
Okay, so the pendulum swung. Instead of creating knowledge de novo, the focus shifted to refining existing knowledge. This brings us to the source rephrasing paradigm. What was the core idea behind this shift?
Right. This is where approaches like WRAP, that's web rephrase augmented pre-training, came in. And then NVIDIA refined it with Nemotron-CC. The core idea shifted quite dramatically. Instead of generating totally new stuff, Smaller, more efficient LLMs were used to rephrase existing web data. The goal was to turn it into higher quality, more task-aligned formats.
Like what kind of formats?
Think of transforming raw web text into, say, clear Q&A pairs or structured instructional passages, maybe more conversational dialogue, tidying it up, making it more useful.
The benefits of source rephrasing, superior coverage, greater diversity, significantly lower compute costs, seem pretty clear. Maney et al. Saw over a 3x speed up in pre-training, you mentioned. Was this really the turning point for the industry, or were there still reservations?
Oh, it was absolutely a turning point. By 2025, this approach really became dominant. Major state-of-the-art LLMs, think Kimi K2, Qwen 2.5, Grok from XAI, even reports about OpenAI's GPT-5. They all reported substantial use and gains from source rephrasing. It marked a critical shift, really, more towards data-driven synthetic data rather than purely model-driven. It combines the web's broad knowledge with controlled style and format improvements. It gave a path forward past the data scarcity issue.
Gotcha. And just to be clear for our listeners, while synthetic data is useful for other things like fine-tuning and evaluation, this paper's deep dive is really focused on its impact during the pre-training phase, right? The foundational stage.
Precisely. The goal here is about foundational improvements, building better general-purpose models right from the start.
Which brings us neatly to BeyondWeb. This isn't just another rephrasing method, is it? It's described as leveraging grounding and diversity. What makes BeyondWeb feel like a new frontier in this space?
Yeah, BeyondWeb is a synthetic data approach specifically designed to improve pre-training efficiency. It does this by strategically combining the broad coverage you get from web-scale corpora with intelligently generated content. The idea is to fill critical gaps in styles, formats, topics that are often underrepresented in just raw web data. It's not just rephrasing, it's smart rephrasing that targets specific shortcomings.
But what kind of strategies are they actually employing to achieve this smarter rephrasing? What does that look like?
They use a really diverse set of generation strategies. So yes, it includes straightforward format transformation, like turning web content into structured question-answer pairs. That's pretty common now. But it also involves more nuanced techniques, like style modification, maybe enhancing a pedagogical tone to make the data better for learning, or even content restructuring to improve the overall information density and accessibility.
Making it easier to digest, basically.
Exactly. The whole idea is to create models that are better aligned with how people actually use language and what downstream tasks demand.
That sounds like a very comprehensive approach. Let's talk numbers then, because the performance comparisons in the paper are pretty striking. How did BeyondWeb stack up against existing datasets? You've got RedPajama, which is non-synthetic web data, Cosmopedia, that generator-driven 1WR app, and Nemotron-Synth, NVIDIA's refined rephrasing method.
Okay, so the Dataloggy AI team trained models using the popular Llama 3.13.2 architecture. Lots of people use that at 1, 3, and 8 billion parameters. They trained them across these different data sets, and the results were genuinely impressive. BeyondWeb consistently achieved the highest average accuracy across 14 different benchmarks. We're talking 57.4% for the 1D model, 60.8% for 3B, and 63.7% for the 8B model.
And how did that compare to, say, Nemotron-Synth, which was considered pretty good?
It consistently outperformed Nemotron-Synth, which was their strongest synthetic baseline, by 3.1 percentage points for the 1B, 2.0 for the 3B, and 2.6 for the 8B model. Consistent gains across scales.
And the speedups. We touched on this, but they're just as remarkable. We're talking real computational savings here, aren't we? This is crucial for anyone working with limited compute.
Absolutely crucial. For the 8 billion parameter model, BeyondWeb reached the performance level that RedPajama, the web data, got after 180 billion tokens. BeyondWeb got there in only 23.2 billion tokens.
Wow, it's a 7.7x speedup.
Exactly. And compared to Nemotron-Synth, it achieved the equivalent performance in just 66.2 billion tokens. That's a 2.7x speed up over another state-of-the-art synthetic method. This translates directly to massively reduced training costs, energy consumption, and importantly, faster iteration times. That helps everyone, big labs and smaller orgs.
This combination of speed and accuracy leads to what the paper calls a new Pareto frontier. What does that mean for us, the researchers and engineers trying to build better LLMs?
Yeah, the Pareto frontier idea, it basically means achieving better results with fewer resources, in this case parameters. The most striking finding, I think, is that their 3 billion parameter BeyondWeb model with that 60.8% accuracy actually outperformed almost all the 8 billion parameter baseline models trained on the same 180 billion token budget.
Wait, the 3B beat the 8B models?
Almost all of them, yeah. It only slightly trailed their own 8B Nemotron-Synth model. This really challenges the conventional wisdom of just scaling up model size. It highlights how much headroom high-quality synthetic data can unlock. You can get stronger models potentially at lower computational cost. It's genuinely doing more with less.
And it wasn't just good on one or two specific tasks, was it? The generalizability across a broad set of benchmarks seems key here too.
That's right. It wasn't just cherry-picking tasks. BeyondWeb consistently got the highest average accuracy and outperformed baselines on 13 out of 14 tasks for both the 1B and 8B models, and 12 out of 14 for the 3B models. So it shows broad, robust generalizability, not just narrow gains.
Plus, it's already been validated in a production setting you mentioned, part of RCAI's AFM 4.5B model training.
Correct. That model used a huge 7 trillion token pre-training dataset, which included BeyondWeb techniques. So this isn't just a lab result. It shows efficacy in a real-world, large-scale scenario.
Okay, so the benefits are clear. BeyondWeb performs well. It's efficient. But what makes synthetic data effective? The paper goes into a pretty systematic evaluation of various factors. They set up experiments using a 1B Llama 3.2 model, 20 billion tokens total, split 50.5 real synthetic.
Yeah, that control setup lets them isolate different factors. One of the first questions they tackled was, is synthetic data's power just about knowledge distillation? Is it simply packing more information into each token, making it denser?
Right, the hypothesis being just compacting information is the key. So they compared Cosmopedia to the generator-driven approach with just simple summarization of web data. What did they find there?
Well, what's interesting is that a simple summarization prompt, just aimed at condensing info, nearly matched Cosmopedia's performance. Summarization got 46.7% accuracy, very close to Cosmopedia's 47.1%.
Huh, so just making it shorter helps a lot.
It suggests that basic information condensation is a significant mechanism, yes. But, and this is important, BeyondWeb still significantly outperformed both, hitting 50.4%. So that indicates that effective synthetic data involves more than just basic distillation. It's not just about information density. There's something else going on.
That's a really crucial distinction. It's not just packing more in. This then begs the bigger question we started with. Can synthetic data actually help us break through that data wall? Because we know just repeating data usually leads to performance degradation. How do they test this idea?
Okay, so they looked at data repetition first. Repeating data twice, which simulates data scarcity, showed a 0.7 percentage point performance drop compared to their full data upper bound baseline. That confirms repetition hurts. Then they tried simple model-driven continuations of existing web data, sort of a naive form of synthetic generation.
Like just asking the model to write more text similar to what it saw.
Pretty much, and that only provided a modest improvement. It basically just matched the full data upper bound accuracy. So simply having the model generate more text in the same vein doesn't really get you much beyond what you'd get just repeating the original data.
So more of the same doesn't really help push past the limit. But what about BeyondWeb?
Right, here's where it gets really interesting. BeyondWeb, with its 50.4% accuracy, surpassed that full data upper bound by a significant 4.2 percentage points.
Wow. It actually beat the theoretical best performance using just the available real data.
Exactly. This strongly demonstrates that strategic, well-designed synthetic data like BeyondWeb can indeed breach the data wall. It's not just filling gaps, it's creating something genuinely better and more effective for pre-training than the raw data itself. That's a potential game changer for the field.
That's incredible. It's not just compensating for limited data, but actively enhancing performance beyond what the raw data alone could achieve. Okay, moving on. How important is the quality of the seed data for rephrasing? If you're going to rephrase, should you use high-quality web data or low-quality web data as your starting point?
Good question. They found that rephrasing high-quality seed data was more beneficial, even if it meant repeating some knowledge that was already in the high-quality web data pool. The combo of HQ-Synth, rephrased high-quality data, plus HQ-Web achieved 49.2% accuracy. That outperformed using LQ-Synth, rephrased low-quality data, plus HQ-Web, which got 48.6%.
So start with good stuff if you can.
Basically, yes. The quality of your input data for rephrasing is crucial. However, it alone isn't sufficient for the absolute best results because BeyondWeb, remember, still performed better at 50.4%. So quality source material matters, but it's not the only factor. The rephrasing strategy itself adds significant value.
Right. Quality trumps novelty in your source, but you still need that sophisticated rephrasing process like BeyondWeb on top. Okay, next up, distributional style matching. The paper notes web data is mostly blogs, news, product pages, but we often use LLMs for chat or Q&A. Is that style mismatch important? Does it hurt?
Yeah, this is super relevant for a real-world application. Does training on one style and inferring on another impact performance? They estimated conversational content is tiny online, like less than 2.7% to 3.67% of web text, even though chat is a huge use case. Their experiments showed that upsampling natural conversational data does improve five-shot performance slightly. It went from 43.2% up to 44.1% when they boosted conversational content to 50% of the mix.
So getting the style right helps a bit. You wouldn't feed an Olympic athlete only broccoli, right? A balanced diet is better.
Exactly. It helps, but the gains saturated pretty quickly. They didn't see much more benefit beyond bumping conversational content to around 20%. So it indicates style matching is useful, it's a piece of the puzzle, but it's not sufficient on its own for maximizing synthetic data quality. It's not the whole solution.
Okay, which naturally leads to the next question. How important is diversity at scale? If a single strategy approach, like only generating Q&A pairs, leads to diminishing returns, what's the answer?
This is where BeyondWeb's philosophy really shines. What's fascinating is that BeyondWeb, because it emphasizes diverse generation strategies, provides both those initial performance bumps and, crucially, sustained improvements throughout really long training runs. This was clear even when they pushed things into overtrained regimes, training 1B models 50 times beyond the chinchilla optimal compute amount.
50 times. Wow.
Yeah, really pushing it. And while other single strategy methods like Cosmopedia tended to saturate or plateau, BeyondWeb kept showing positive performance trends. This really drives home that diversity in your synthetic generation is critical to avoid those diminishing returns and keep the learning benefits going as you scale training up to trillions of tokens.
Makes sense.
Yeah.
Don't put all your eggs in one synthetic basket. Now let's talk about the generators themselves. Who should actually do the rephrasing? Does the specific LLM family you use matter much? Like, does using a Llama 3 model make better rephrased data than, say, an Olmo model?
Okay, this result was quite counterintuitive, actually. They tested 4 different generator models: Olmo 27B, 5414B, Mistral 7B via 0.3, and Llama 3.18B. They used the exact same rephrasing prompt for all of them. And what they found was that the quality of the resulting synthetic data was remarkably consistent across these different model families. Less than 1 percentage point difference in the downstream task performance.
That's genuinely surprising. You'd intuitively think a generally more capable LLM, one that scores higher on benchmarks, would produce better synthetic data.
You absolutely would. And get this. Despite the rephrasers themselves having up to a 7-point spread in their own general benchmark accuracy, the Olmo 27B model, which actually had the lowest benchmark accuracy among the ones they tested, it produced the highest quality synthetic data in their downstream tests.
No way. So the worst generator made the best synthetic data for training.
In this specific rephrasing context, yes. This finding is potentially a huge deal. It suggests that you don't necessarily need the absolute biggest, baddest frontier LLM to generate high-quality synthetic data via rephrasing. This could really democratize access to these powerful data creation techniques. Smaller labs, researchers with fewer resources, they might not need access to the most expensive models to do this effectively. Rephrasing seems to be a more generic, generator-agnostic capability than we might have thought.
That is a huge deal. Okay, and speaking of size then, does the size of the Rephraser model itself matter for the synthetic data quality? If family doesn't matter as much, does scale?
So they tested this specifically using Llama 3 models of 1B, 3B, and 8B parameters to generate the synthetic data. And yes, larger generators do generally produce better synthetic data. The 8B model's output led to better downstream results than the 3Bs, which in turn was better than the 1Bs. The improvement jump from the 1B generator to the 3B generator was quite substantial, actually about 1.5 percentage points in downstream accuracy.
Okay, so bigger is generally better here, but I'm guessing there's a sweet spot. Maybe diminishing returns kick in.
Exactly. They observed clear diminishing returns beyond the 3B parameter generator. Going from the 3D Llama 3 Rephraser to the 8B one only yielded an extra 0.4 percentage points gain downstream. So while larger models are technically better, that small extra gain might not be worth the significantly higher cost of running the 8B model for generation. It makes smaller models, like a 3B parameter Llama 3, look like a highly cost-efficient and practical choice for generating high-quality synthetic data.
That reinforces the democratization point, too. You don't need a massive cutting-edge model. A good mid-size one might be the sweet spot for cost and quality.
Precisely. It makes this powerful technique much more accessible.
So wrapping things up, what does this all mean for you, the listener? Whether you're building models, researching AI, or just trying to stay ahead of the curve, this deep dive has shown us that pre-training LLMs definitely hit that data wall. But synthetic data, done right, offers a powerful, scientifically rigorous way to potentially break through it.
Yeah, the big takeaway is that generating high-quality synthetic pre-training data is complex. It's costly if done wrong, and it requires jointly optimizing a whole bunch of factors. There's really no simple silver bullet solution. Naive approaches might give you modest improvements, or they could even hurt performance, all at great computational cost. But as BeyondWeb really demonstrates, thoughtful, scientifically rigorous source rephrasing can yield transformative improvements. It's about being intentional and applying deep scientific understanding.
It's absolutely not just about throwing more data, synthetic or otherwise, at the problem. And that really leads to some fascinating questions for the future, doesn't it? For example, you mentioned inherent repetition in synthetic data, the kind that comes from the generator's own biases or the prompting style. How does that kind of repetition impact scaling laws differently than just explicitly repeating chunks of real data? That feels like a whole new area for research.
Definitely. We don't fully understand those dynamics yet. And another thought, given how effective smaller models, like that 3B Llama 3, prove to be at rephrasing, can we push that further? Could we explore using even smaller rephrasing models to truly democratize access to high-performance LLMs, especially for researchers or groups with really limited resources? What would it take to make these techniques accessible to virtually everyone?
And maybe thinking even bigger picture. It's not just about text, is it? Could these kinds of rephrasing or data enhancement techniques be applied to other domains, or even different data modalities altogether? Imagine the possibilities there. What could this mean for generating better training data in areas like image generation or maybe music or even scientific data?
The potential to adapt these core ideas, identifying shortcomings in existing data and strategically generating enhancements, could be really broad.
Absolutely. Well, we hope this deep dive into BeyondWeb has given you some profound insights and maybe sparked some new ideas for your own work. What new avenues does this open up for your AI research or projects? How might you leverage these insights about synthetic data, rephrasing, and quality to overcome data challenges you might be facing? Lots to think about. We'll see you next time for another deep dive.